For this section, we're going to go beyond what we did with the frequency tables and look at conditional probability with a formula. So this is the conditional probability formula. If I want to find the probability of B, given that A happened, then I need to find the probability of both B and A happening together and divide that by the probability of A happening. This only works if probability of A is not equal to 0, because if it were equal to 0, we'd be dividing by 0, which is always a problem. All right, so we're going to practice using that formula. And so it's the probability of B given A. So we're going to look at the probability of B and A and divide that by the probability of A. So B and A would be 1/2. Divided by probability of A would be 3/4. And when we're dividing fractions, we can multiply by the reciprocal. So it's going to be 1/2 times 4/3, which reduces to, if I take a 2 out, that would be 1, and that would be 2. So it reduces to 2/3 is the probability that, given that A has already happened, the probability of B. And then if I do the same deal, but with probability of A, given that B has already happened, so that's going to be A and B divided by the probability of B. So for that, that's going to be 1/2 again, and the probability of B is 2/3. So we multiply by the reciprocal, so I have 1/2 times 3/2. And so that would be 3/4. So what I also notice about this is that this is an independent event because the probability of B given A is equal to the probability of B, just regular probability of B, and the probability of A given B is equal to the regular probability of A. So this is an independent event. I didn't ask you that question, but it's always good to be thinking about these things. So this event is independent because it doesn't matter whether A happened first, the probability of B is going to be 2/3. It doesn't matter whether B happened first, the probability of A would be 3/4. Right? So here's another one. We're going to use that formula. So the probability of A and F divided by the probability of A is going to equal the probability of A given F. Probability of F given A. I wrote that backwards. So if I look at this, the probability that someone is a fan, given that they plan to attend the concert, is 70%. We don't know the probability of A and F, but we know that the probability that someone is going to attend the concert is, oops, I wrote that wrong. So the probability that someone is a fan, given that they're attending the concert, is 80%. The probability that someone is attending the concert is 70%. So if I multiply both sides by 70%, I get that the probability of A attending and a fan is going to be 0.56 because I multiply both sides by 0.7. Okay. If I do probability of A and not F, that's going to be the probability of not F, given that they're attending the concert. So that's what we want to find out, probability of A and not F, divided by the probability of A, 70%, and then probability that they're not a fan, but they're attending the concert. Well, if they're not a fan and they're attending the concert, that would be 20%. That's the remaining students. The 80% are fans, 20% would not be fans. So then we multiply both sides by 70 again, so we get the probability of A and not F would be 0.14. So 14% chance that someone is going to the concert, but they're not a fan of the band. All right. Here's another one. We're trying to decide whether B and T are independent or dependent events. So we're going to use that formula. Probability of selecting a blue card given that we chose a card that has a 3 on it. So that's going to be the probability of blue and 3 divided by the probability of 3. So blue and 3, there are 2 out of 6 cards. And probability of a 3, blue and, yep. And probability of a 3 would be 1, 2, 3 out of 6 cards. So the probability of blue and given that you've already chosen a card with a 3 on it, would be 2/6 times 6/3. The 6's divide to make 1, so that would be 2/3. Okay. Now we want to check the probability of just blue. So if I chose a random card, is it blue? Well, there are 3 blue cards out of 6, so the probability of blue would be 1/2. Since these two numbers don't match, they are not independent events. The probability of blue, given that you chose a 3, is much higher, 2/3, than it would be of just choosing a blue card. So the answer is no. I could have checked the other way. I could have checked 3 given blue. I would have resulted in an answer of no either way. All right. That is conditional probability with that conditional probability formula.